Determine the rate of change. Before we jump into this one, we need to recall a few things from algebra. First thing is the slope formula. We know that slope is m, and this is also called the rate of change. M equals the change in y, so y1 minus y2 over the change in x's, so x1 minus x2. So this doesn't matter what kind of function we're using. If we want to find an average rate of change, we're going to be taking our y values and subtracting them over our x values and subtracting them. Okay, and then our parallel lines. If we want to find a line that's parallel, so exactly the same rate of change, then we just look at our m. So our m parallel is going to equal our original m. They're going to be the same. So once we find our original m, then we already know our parallel m. And perpendicular lines, m perpendicular is going to equal the opposite sign and the inverse of the number. So opposite sign, opposite fraction. Flip the sign, flip the fraction. And basic forms that we will use quite often, slope-intercept form and point-slope form. Slope-intercept form is y equals mx plus b. M being your slope, b being where it crosses the y-axis, y-intercept. Now, this is how I want your answer to be written, but in order to find your answer, in many cases, you will have to use point-slope form, which means y minus y1 equals m times the quantity x minus x1. All right, so this x1 and y1 is just one of the points that you're given. So that information is all a review and what you'll have to use to go on. For our first example, what we want to do is we want to find an equation in slope-intercept form. So we're going to use the points -2, 5, and 6, -4 to find the equation of a line. So the first thing I'm going to do is find my slope. M equals, pick one of the y's, which is 5, minus my other y, which is a -4, over my -2, make sure you match them up, minus 6, so that's going to give me double negative, makes that a plus, so 5 plus 4 is 9, over -2 minus 6 is -8, so my slope is -9 over 8. Okay, so now I'm going to put that into my point-slope form, y minus y1 equals -9 over 8, x minus x1. So then I can pick one of my points, so y minus 5 equals -9 eighths, x minus negative plus 2. Okay, so now I solve. So I have y minus 5 equals -9 over 8 times x minus 9 over 4, because if you multiply here, you get -9 over 4. All right, then I add the 5 over, and I have y equals -9 over 8x minus 9 over 4 plus 20 over 4. 20 over 4 is equal to 5, so I just converted it so that I can add these fractions together. And I have y equals -9 over 8x plus 11 over 4. And that would be your final answer. For this next one, we actually want to find a parallel line that is through the point 0, 0. So the point we're going to be using is 0, 0, but we first need to find our slope of our parallel line. Well, m parallel is equal to m, which our m we already found out before to equal -9 over 8. So that is what my m is still going to be equal to. So I have, now I'm just going to put in my 0, 0, y minus 0 equals -9 over 8x minus 0. And then obviously in this one we don't have anything that we need to add together, so we just distribute here and then add the 0 over, and we get y equals -9 over 8x And that's actually our parallel line through the point 0, 0. And the next one here, we want to do the same thing, except we want to find the perpendicular line through 0, 0. So we need to recall that m perpendicular equals negative 1 over m. So opposite inverse. Well, my original was a negative, so now we're going to have a positive, and then if I flip my fraction, the 8 will be on top, the 9 will be on bottom. So m perpendicular is going to equal 8 over 9. All right, so now I have y minus 0 equals 8 over 9 times x minus 0. Make sure that if you're not trying to go through the point 0, 0, then you put in your other points for 0 and 0. It's just lucky that it happens to be that point. So we add the 0 over, we distribute in our 8/9, and we have y equals 8 over 9x as our final equation. In this next example, what we want to do is find the average rate of change. This one's a little different because instead of being a line, our equation is actually a parabola. It's an x squared minus 4. So we can still find an average rate of change. It's not going to be exact for everything, but at a certain point, we can find a rate of change. So our rate of change is m. So we just need to take m, and then we need to take our f of x1 value, which is y1, minus our f of x2 value, which is our x2 y value, or y2 value, and then just over x1 minus x2. So what I'm going to do is I'm going to take my 8 is my x1 value, and my 7 is my x2 value. So I'm going to take f of 8 minus f of 7 over 8 minus 7. Okay, so basically what I did to start out with was I took this y out and I replaced it with f of x, because I know that f of x equals y. That's function notation. So I'm going to change it to that so that it makes more sense right off. And then I'm just going to put in 8 and just solve. So if I put 8 in, 8 squared, make sure you put it in parentheses so I don't get confused, minus 4. So that whole thing is f of 8 minus my f of 7. So that would be 7 squared minus 4. All over 8 minus 7, which is 1. Okay, so if I continue solving from there, I'm going to see that 8 squared is actually 64, minus 4, minus 7 squared is 49, minus 4. Put that parentheses in there so you don't get confused. The next step, 64 minus 4 is 60, minus 49 minus 4 is 45. Finally, 60 minus 45 is 15. So that means my average rate of change on that interval is 15, or 15 over 1 if you want to think about it that way. Those are your notes over determining the rate of change in problems. Go through the practice problems, especially go through the ones about the average rate of change, because those are new and a little bit more complicated. And then prepare for your quiz over the material.